All right, here's the study guide solutions. Number one is to graph the derivative of this. When I have a line and take the derivative, I'm looking for the slope. So the slope of this line is 1. So I'm going to draw a horizontal line at 1 all the way up to 0. So there's the beginning part of the graph. Then the second part of the graph, I notice it's all decreasing. That means it's below. I also notice it's concave up and then concave down. So when I am thinking of the second derivative, so it's concave up and then concave down, it actually ends at 4. That means it rises and then it falls. At 2, there's a slope of 0. So that means it rises and then falls, and there's a hole at the end, and there's a hole here too. So it rises and then falls. So it's concave up means it rises, concave down means it falls. At 2 is a point of inflection, so that's a turning point for this first derivative, and both ends are holes. That's why they're there. Number 2, this is a typo, so I changed it on the PDF I put up there. So this should say the second derivative in each spot. So these are my critical numbers. When I plug 2 into the second derivative, I get 0. That means no concavity, not maximum or minimum. When I plug 4 into the second derivative, it's a positive answer. So at 4 is concave up, which is a minimum. At 5, it's equal to 0, neither. So there is no maximum here. The other numbers don't matter. It's only 2, 4, and 5. So it starts with the critical numbers, plug into the second derivative, and see if the answer is positive or negative. All right, number 3, the slope of the curve here at this point. And is it a maximum, minimum, or neither at the point? So step 1 is to plug in 1, 3 into the derivative. I need to know that this gives me a 0 for an answer. So by plugging in the point, the answer is 0. That means it's a critical value. So in the derivative is equal to 0, it's critical. So 1, 3 is critical. So it could be a maximum or minimum. Then I need to take the second derivative. And to take the second derivative, I need to do the quotient rule, which is the bottom times the derivative of the top minus the top times the derivative of the bottom. Now, the bottom is y, so the derivative of y is 1, but it needs the hook y prime when we do it implicitly. And then the bottom squared. Then we're going to plug the point into the second derivative. If the answer is positive, that means it's concave up. That means it's a minimum. If it's negative, that means it's concave down, which means it's a maximum. So for the y coordinate, I plug in 3. For the x, I plug in 1. Y prime, well, the derivative at 1, 3, the answer is 0. So I can actually plug in 0 there. And again, the y value is 3. So that when I simplify it, I can see that the second derivative is positive. So that means at 1, 3 is a maximum. All right, moving on. The function 3x squared minus 6x from 0 to 3. The average rate of change is equal to 3. That's AROC. And then it says find the x value where the IROC, that is the derivative. So I need to find the derivative, which is 6x minus 6, is equal to the average rate of change. So I take the derivative equal to the average rate of change, and then I solve it. So I'm going to add 6 and then divide. You could also, don't even do it. So that's a great answer. 9 over 6 is the answer. Don't even reduce it down. All right, number 5. It says find the average rate of change from 0 to 2. So step 1 is I need to plug in 2 and plug in 0 to find y2 minus y1. So when I plug in 2 and when I plug in 0, I now have my y values. So the average rate of change then is y2 minus y1, and then the denominator comes from the interval. So this is 2 take away 0. So if I put this together, The average rate of change is 2. To find the instantaneous rate of change, I take the derivative, which is 2x, and then it says now find the c value for the mean value theorem. So that means you make them equal. Oops, take the derivative and make it equal, and then solve. So divide by 2 and you get your answer. So that c value is 1. We should really write down the c value then is equal to 1. And that is definitely in my interval. So at 1, the AROC equals the AROC. All right, number 6. Find the absolute minimum here. This is a table of values question. We start with the interval. So the ends of the interval are -1 and 2. Then we find what are called the critical numbers of the derivative. So we take the derivative, make it equal to 0 and solve it. I'm going to solve this by factoring. So one answer is 0. The other answer, this is what I'd have to solve. So if I subtract 8 and divide by -3, a negative divided by a negative is positive. Now the next question is 8 over 3, is it in my interval from -1 to 2? So 8 divided by 3 is 2 and 2/3. So it's more than 2. So it's not in the interval. So this one would be not used in the table of values, only if it's in the interval. So 0, though, is in the interval. That would be used. And then you find the y value by plugging into what y equals. So if I plug in -1, that's a negative times a negative. So that's +1 plus 4, that's 5. Plug 2 in here. 2 cubed is 8, so it's -8. 2 squared is 4, that's 16. So it's -8 plus 16. And then if I plug in 0 and 0, so what is the absolute minimum? And the answer is 0, because it's the smallest y value in the interval. Absolute minimum. So this is my answer. All right, for this function, find the extrema points, which are the maximum and minimum. How do I do that? So I take the derivative. Done. I make it equal to 0. Got it. I would also see if there's any values that make the derivative undefined. There isn't. All right, I'm going to add 12. I'm going to divide by 3. And then when I square root, I get positive and -2. I'm now going to draw a number line for the first derivative. And into there, I'm going to plug it into the derivative, which is right here. So plug in -3. And that gives you a positive answer. Plug in 0, plug in +3 or 4 or 5. And so these are my sign changes. So that means it increases and then decreases, it decreases and then increases. So the points would mean the max would be at -2, and then I have to plug back in here to solve it. So that's -8 plus 24. So 24 take away 8, 16 plus 1, I think it's 17. And then the relative minimum, I would plug in +2 in here. So that's 8 take away 24, -16 plus 1. I get -15. See if that's right. I think so. I'm going with it. All right, next one. Find the x-coordinates of the point of inflection. So that's the second derivative. So the first derivative is 4x cubed minus 6x. And the second derivative is 12x squared minus 6 equal to 0. I need to find the critical numbers of the second derivative. So I'm going to add 6, and I'm going to divide by 2, and I'm going to square root. So it's positive and negative root 2. So I'm going to draw a number line for negative root 2 and positive root 2. And then I'm going to plug in the values here into the second derivative. So like -3 or -5, if I square it, it becomes a positive number and way bigger than 6. If I plug in 0, this answer is negative, and then if I plug in a positive number bigger, it'll end up being positive. So what are the x-coordinates of the point of inflection? So where's the sign changes? And the answer is positive and negative root 2. That's where the point of inflections are. On to the next page, number 9. Find the x values of the maximum and local minimum points of the functions whose derivative is given. So this is really the derivative here, not the function. So the critical numbers are the zeros of these. So x, that's 0, x plus 2, the 0, and x minus 1, the 0. So those are the zeros. Draw a number line for the derivative, and it's negative 2, 0, and 1. So that's the order, negative 2, 0, and 1. And then we're going to plug in negative 3. So that's a negative times a positive times a positive. So the even exponents make it positive. And then we can do the multiplicity. So if it has an even exponent, so negative 2 comes from this factor. An even exponent means the sign stays the same. 0 comes from here. It's an odd exponent, so the sign changes. Positive 1, it's an even exponent, so the sign stays the same. So we have 1, and what are we looking for? Oh, maximum and minimum. So we just have a minimum point. So we have a relative minimum point at 0. And that's it, right? It says find the x values. So at x equals 0 is all we got. There's no y coordinates. We don't have a function to plug into. So at x equals 0 is a minimum. There is no maximum. All right. This graph is concave up on what interval? So that's the second derivative. So the first derivative is 4x cubed minus 24x. The second derivative is 12x squared minus 24 equal to 0. We're going to solve this. So that's 24 divide by 2. Divide by 12, I mean. That's 2. And again, you get square root, positive and negative root 2. So we're going to draw a number line for positive and negative root 2. Second derivative, so we plug into the second derivative. So if I plug in negative 3, or if I plug in 0, or if I plug in positive 3, those are the signs. And so it's concave up from negative infinity to negative root 2 and root 2 to infinity. So there are two intervals where it's concave up. All right, find the intervals in which the function is increasing if that's the derivative. So they already give you the derivative. So step 1 is to make it equal to 0 and find the critical numbers. So I'm going to factor out an x, and then I'm going to keep factoring. So the two numbers that fit here are negative 4 and positive 1. They multiply to negative 4 and add to negative 3. So I have three critical numbers. So that's 0, 4, and negative 1. We're going to draw a number line, and we're going to label in order negative 1, 0, and 4. Now, I want you to notice all the exponents are odd. That means the signs are going to change every time that it goes from one critical number to the next. So if I plug in negative 2, I get a negative times a negative times a negative. Got it. Now the signs are going to change all the way across because all the exponents are odd. And so where is it increasing? It's increasing from 1 to 0, and it's increasing from 4 to infinity, where the first derivative is positive. All right, find the absolute minimum and maximum of this from 0 to 3. This is a table of values question again. We have to take the derivative, make it equal to 0, and solve. So I'm going to add 4 and divide by 2. So those are my numbers I'm going to use. I plug them into the y equation. So if I plug in 0, if I plug in 3, 3 squared is 9. Take away 12, negative 3 plus 1. 2, 2 squared is 4. 4 times 2 is 8. So it's 4, take away 8. Negative 4 plus 1, I get negative 3. Is that right? Maybe it's negative 5. Let's try again. 4, take away 8 plus 1. Now it's negative 3, right? When I plug in 3, it's 9, take away 12. No, I got it. So the minimum is negative 3, and the maximum is positive 1. All right, a stone is projected vertically upward with this equation. How long will it take the stone to reach its maximum height? So how do I find a maximum? As I take the derivative. So I'm going to take the derivative, make it equal to 0, and if I solve this, the answer is 2 that makes it 0. So at what time? At 2 seconds. Now what's the height at 2 seconds? I got to plug that back into the equation. Without a calculator, you can do this. So this is -8 plus 16 plus 25. So that's what? 41, take away 8. All right, so I get 33 feet. In feet, yeah. All right, turn the page. The graph at the right here, we have a function. Find the C value that satisfies the mean value theorem. So I need to find A rock. So I'm going to use this interval. So I'm going to plug in 3. So that's 2/3. 3 cubed minus 2 times 3. So I'm going to do that first. This is 27 divided by 3, which is 9. 9 times 2 is 18. 2 times 3 is 6, and then put it all together. I'm also going to plug in 0. Well, that answer is going to be 0 when I plug in 0. So then when I find A rock, it's going to be y2 minus y1. And then I use the interval, 3 take away 0. So the answer is 4. Then the derivative, so 3 times 2/3. The 3's cross out, leaves me 2x squared. The derivative of negative 2x is -2, and then make it equal to the A rock, which is 4. Add 2. Divide by 2, and then square root. Now normally the answer would be positive and negative root 3, but we only want the answer in the interval. So it's only positive root 3, and that's the C value. All right, number 15, you're given the function, the derivative, and second derivative. Can you figure out all the analysis for this function? The domain comes from the function in the denominator. Is there any value that makes the bottom 0? The answer is no. All numbers will work. For the x-intercept, look at the numerator. We have no variable there. So if you take the top equal to 0, you can't solve it. So there is no x-intercept. To find the y-intercept, you plug in 0. So when you plug in 0, you're left with 2 divided by 1. So the y-intercept's 2. There is no vertical asymptote because nothing makes the bottom 0. The horizontal asymptote comes from the power terms. When the bottom is more powerful, the horizontal asymptote is 0. So that's the pre-calculus. Now the calculus part. First derivative, what are the critical numbers? So in the numerator, equal to 0. 0 is a critical number. Nothing on the bottom. So the only number is 0. Plug in any number smaller than 0 into the first derivative. So a negative times a negative is positive. And then plug in any number bigger than 0 into the first derivative. That's going to be a negative answer. So that means it is increasing from negative infinity up to 0 and decreasing from 0 to infinity. For the second derivative, I need to look here. This takes us a little bit of work. We need to take the numerator equal to 0 and solve it. You could add 4. You can divide by 4, square root it, and I get 2 answers, positive and negative 1. So we need to go here, negative 1 and positive 1. And then into the second derivative, if I plug in like negative 5, the answer is going to be positive. If I plug in 0, the answer is going to be negative. And if I plug in like 5 or 6 or 7, we're going to get a positive answer. So this is the concavity part. So it's concave up from negative infinity to negative 1. It's also concave up from 1 to infinity. It's concave down from negative 1 to positive 1. Now, where is there a maximum point? That comes from the first derivative number line. So we do have a maximum here at 0. And then the y-coordinate, when you plug in 0, we already plugged in 0. The answer was 2. So that's the y-intercept is a maximum. We have no minimum because on the number line we only have a maximum. The inflection points are here. It's positive and negative 1. Now, when I plug positive 1 and negative 1 in to find the y-coordinate, when you square it, you get the same answer. So 1 squared plus 1. So it ends up being 2 divided by 2. And so both positive and negative 1 give you the answer 1. All right, last page. One point on this curve is 2, 4. Use a tangent line to approximate. So for that, I need 3 values. I need to know the x, the y, and the slope. The x is 2, the y value is 4. The slope is found by taking the derivative. So 4 times 1/4 is 1, and then subtract 1 to the exponent, and you get x cubed. Then you plug the x coordinate into the slope. So the x coordinate gets plugged into the derivative to find the slope, and the slope is 8. So the tangent line is 8, x subtract 2 plus 4. Then we plug in 2.01. Be careful of your decimals, and then you get the answer. So, 2.01 take away 2 is 0.01. This is like 8 pennies. So I'm going to write 8 pennies down, and then when you add it up, it's 4.08. Number 17, you have a large rectangle, and it's divided up into these smaller rectangles using 1,200 feet of chain link fence. Find the maximum area. So my goal is the area. So this is an optimization question. What I'm looking for is area. So what's an equation that describes the area of this diagram? And that's just x times y. We have too many variables here. We only want one variable, then take the derivative equal to 0 and so on. So we need to understand there's another sentence here about 1,200 feet. That's the chain link part. So how many x's? So we have an x, an x, an x. So how many? 3 x's. How many y's are there? 1, 2, 3, 4 of them. So you have 3 x's and 4 y's, and that makes up all the feet of fencing, and that's 1,200. And then I need to solve for one of these. I'll solve for y. So I'm going to subtract 3x and divide everything by 4. So that when I do that, 12 divided by 4, and then 3/4. So you get 300, and then it's negative 3/4 x. And then I'm going to take that value and come back here. So where there's a y, I'm going to plug in 300 minus 3/4 x. And now I have only x's, which is what I want. Before I take the derivative, I'm going to distribute. That's 300x minus 3/4 x squared when you multiply. Now finally, so the hardest part is creating the equation and make it calculus friendly. Now that we're ready to go, it's just the derivative equal to 0 and solve it. So we're going to take the derivative, because we're just finding a maximum value here. So there's the derivative equal to 0 and solve. So I'm going to add, this is 3 over 2, so I'm going to add that. And then I'm going to do the reciprocal and then think, what's 2/3 of 300? And that answer is 200. You can cross out and make it 100. And multiply to find the y value right here. 300 minus 3/4 times 200. Oh, it just says find the x value, so I don't even need to do this. So what's the x value that maximizes the area? And the x value is 200 feet. Perfect. Number 18. This is a derivative graph. And for some of you, it might be easier to draw a number line for the first derivative. So for this one, it's negative and then positive. So we need to know the x-intercept. So when is the derivative equal to 0? Those are my critical numbers. Those are my x-intercepts. That's negative 7, that's negative 1, that's 5, and that's 9. And then, is it below or above? So the first part is below, then above, then below, then above, and then it ends off below. So those are the signs for the derivative. So this is a minimum. So when it says, where is there a minimum? This is a typo. This should say maximum. So at negative 7 is a minimum. At negative 1 is a maximum. At 5 is a minimum. And at 9 is a maximum. Where's the point of inflection? That's the turning points of the derivative graph. So it increases, then decreases. Where does it change? So at negative 3, it then decreases and increases as concave down, then concave up. So what's the turning point? And then here again, it increases, then decreases. Where's the turning point? So the turning point of the first derivative are your points of inflection for the function. All right, almost there. Number 19. The graph of the derivative is shown over here. At what x values do we have a maximum? So a maximum is when you go positive to negative. So there's a maximum when x equals 4. A point of inflection is the turning point. So it says there's a maximum at x equals 1, so that is the point of inflection. If it asked for the minimum would have been at -1. All right, number 20, we're almost there. The derivative at 3. Well, at 3 is this right here. How do I find the derivative off the graph? It's the slope of this tangent line. So look at this tangent line. What's the slope of it? I go down 2 and to the right 1. The slope there is -2. That is a definition of derivative. So the derivative is the slope of the tangent line. So that tangent line, the slope at that point is down 2 and to the right 1. Give an equation of that line. Well, I need a point, which I have here. We have x equals 3. What does y equal? It equals 4. So that's all I need with the slope. So it's y equals -2, x minus 3, plus 4. Looking off the graph. And then use that to approximate 3.1. So if I approximate 3.1, plug in 3.1 into there, and you get, that's 0.1, that's -0.2, and that's 3.8. All right, one left. A rectangular garden with an area of 800 feet squares protected from vegetables, from rabbits. Find the dimensions of the garden that require the least amount, it's a minimum, of fencing if one side of the garden is protected by a barn. So I got to draw a rectangle, but not one side is a barn. So this side here, no fencing. And so this is a rectangle, so I'm going to label it X and Y. Those are the dimensions. And so what I'm looking for is the least amount of fencing. So the fencing would be how many X's plus how many Y's. We have too many variables. The area of this rectangle would be X times Y, and we know the area is 800. So I'm going to get Y by itself by dividing by X, and now I know what Y equals. I'm going to plug that in for Y. Instead of writing 800 over X, I'm going to write 800 X to the -1 so that I can do calculus with it. Now we need to take the derivative and subtract 1 to the exponent and then make it equal to 0. At this step, it's easier to write it as algebra. So instead of X to the -2, I write it with a fraction. This is also the derivative. And then I'm going to solve it. So I'm going to add the fraction to the other side. I'm going to multiply by x squared. I'm going to divide by 2 so that x squared equals 400. And then I'm square rooting so that x equals positive or -20. But we have a real rectangle, a real fence, so it's not a negative value for that rectangle. So it's positive 20. I'm then going to draw a number line for the first derivative. Obviously, you can't have negative values. So pick a number between 0 and 20 and plug it in here. So if you plug in positive 1, you get a negative value. If I plug in a number like 30 or 40 and square it, this fraction becomes smaller than 2. So now it's a positive value. And 20 gives us a minimum value. So the question is, find the dimensions. So we just found one of them. To find the other dimension, we need to plug in what x equals, which is 20. So 800 divided by 20 gives me the other dimension. And then write a sentence. So a dimension of, 20 feet by 40 feet will require the least amount of fencing. And you did it. Great job working on the study guide. Again, I recommend that you print out a blank one and try it again without the video. Try it and then see how many you can get right and keep trying and keep practicing. I believe in you. You're going to do well on the test. Mr. G Math. Mr. G, over and out.